Now let's use histograms and box plots to describe data. So to begin with, I need to show you how to make a histogram. And this is the data from the quiz scores, and you want to organize it first. You want to determine the range, in this case the max, which is 100, minus the min, which is 5. So the range is 95. And we have to determine the number of groups that we want to have in our histogram. 10 is usually a good place to start. You can adjust that, but if you do 3, you're not going to have enough to see the shape. So we want enough classes, as we'll call it, to see the shape of the histogram. Now, if you make the shape super small, then you actually tend to lose some of the, if you make the groups super tiny, then you actually lose some of the shape. Class width is basically the width of each group, and that's just basically your range divided by your number of groups, and you round up. So we've got 95 divided by 10 is 9.5, so we'll say our groups are 10, size of 10, width of 10. Then you can create what's called a frequency table, and it's basically a tally chart. And I'm saying, here's the class. So any quizzes with scores from 1 to 10, I have one of those. 11 to 20, nobody. 21 to 30, I've got one. And then you can see I have the rest of these scores in here. Now to go ahead, you can actually make a histogram on your calculator. And here you want to make sure you hit Stat and then Edit so you can go ahead and look at the data in your table. So here I am, Stat, and then Edit, hit Enter, and you can see the list L1, and it has all the data points right there. After that, you're going to want to press second, Stat Plot, and then the graph button. And so, select the histogram, make sure the plot's on, select that histogram right there. Notice I got it off and then I put it back on. Make sure you have the right list, that should be L1, which is this button, which you can get by second blue L1, then graph. And you can see there, and you can do Windows Zoom 9 to enter, but you can also adjust the window settings so you have the min, and I'll come back to that again. Let me hit play for you again and come here. So after we hit graph, that was a little quick. There's histogram, adjusting the list again, and graph. You basically can come to this window section to adjust the settings. Here I have X-min is 1, X-max is 101, and the window right there, the width is 10. And then when you press graph, you adjust it. So you can adjust any of those values. If you use the automatic value, it may not quite give you the plot or the histogram that you normally would be expecting. Because for quiz scores, honestly, we're going to be looking in groups of 10. And I can promise you this will give you weird windows of fractions if you want, or decimals. And normally we deal with integer windows. Not always, but normally. So when we're describing the shape of a histogram, we're primarily going to focus on data that has one peak. This is called unimodal. And then there's symmetric, which means if you folded it in half, it would both halves look roughly the same. It's not skewed. In those instances, the mean and the median are in the same point. We also have still unimodal data that can be negatively skewed. So here you can see the mean and the median are not the same. The mean's actually going to be closer to here, whereas the median's probably going to be over here on this graph. So the mean is less than the median. And finally, positive skewed. The mean is greater than the median. It's to the right. And the reason is that we have outliers in both of these that are skewing the mean, either negatively away from the median or positively above the median. So shouldn't the median and the mean be the same? Well, the median is actually the equal areas point. So where you divide the points in half. You remember how I was doing that with the quiz scores. The mean is the balance point, where it would balance on the curve if it was made of solid material. And remember, it's the average. Extreme values don't usually influence the median much, because if it's the halfway point among all the data points, it's not really saying how having one extreme point further away than another one doesn't really affect where you slice those points in half. But extreme values, since we do affect the mean, because we add up the values to get the mean, and if we have a really high value, that's going to make our sum larger. If we have a really low value, that's going to make our sum smaller. So it will affect the mean. And what it does is it pulls the mean away from the median in the direction of the outliers. So here's my box plot that I generated after I cleared my list and put in my new data. And here's the histogram. You can see the box plot and the histogram look quite similar. The advantage of the box plot is you can really identify the median, where it's a little bit harder from a histogram. Here, the min is 5, and then we have 28, and then my low whisker, I'm going to call this low whisker, is 40, and then the Q1 is 60, the median is 70, this is 80, and that's Q3, the upper quartile, and then we have 100. So if I did my RQR, it would be from 60 to 80 or 40. I do have the outliers at 5 and 28, and I happen to know that the average from the data is 67. These guys are pulling down the average, so that's why the mean is lower than the median. So we would say that this is negatively skewed. If I'm trying to compare more than one class, basically all you're going to do is go into that stat and edit and put your data in the list, and I've already entered it because you don't need to watch me do that. And then you're going to make sure that the plots are turned on for all of them. So I'm going to show you the plot for 2, and you can see, make sure it shows list 2. It's going to default to list 1. So I'm going to show you how to change that. Make sure you hit clear to get rid of it, then hit the name you want to put in there. I didn't really want list 3 in here, so I'm going to put list 2 back. And then we go make sure the plot 3 is all set, and we have the same type, the right list. We hit graph, and you can see the data here. So now I'm tracing over here on the left through the data, and basically it gave me all these numbers. So I looked at the traces from these. I didn't actually go calculate them. I let the calculator do it for me. There is a cool stat var, which I'll show you, and it will also do your mean for you. So I pulled that off the calculator too without having to do it. You should never have to add up all your numbers and calculate the mean when you're taking statistics. Okay, so the thing you should be able to do is start making comparisons. For example, I could say that my L1 class grades are more tightly packed around the median of 70. So I can look up, there's my 70. And you can see it's more tightly packed. But I do have some outliers here. Okay, so that is definitely affecting the average. L3, that's this class here, has the highest median grade. So either I did a better job of teaching this class, or I just have kids who work harder in there. And my Q3 is 100. So it's a very high Q3. I don't even go beyond because many of my students had hundreds in this group. Then finally, well, L3 also appears to be negatively skewed because, you know, you've got these that are kind of pulling on the average down here. And L2 looks the most symmetric of the data, I would say. It's roughly symmetric. And you can tell that the mean and the median are nearly the same. In terms of medians, my highest class I would say would be the L3 class, definitely. I need to worry about these guys down here. And I've got a bit of a spread in my L2 class, which I'm okay with the spread when it's high like this. And I'm less okay with the spread when it's low. So what should you include in your description when describing the data? Well, the SOCS is a great acronym. It's spread, which for right now, we've only talked about IQR really. In the next lesson, we will be using standard deviation. So that's how wide your graph is in terms of IQR or later standard deviation. Outliers, you need to include outliers when describing data. If there are no outliers, it's pretty easy, say no outliers. But if you do have some, and remember, you can use the IQR times 1.5 rule to figure out if you have outliers. For the center, provide both the median and the mean. There will be times that the median's more appropriate and the times that the mean is more appropriate. Usually, if it's symmetric, you can use either one. And then finally, the shape. Is it symmetric? Is it skewed positively or negatively? And hopefully it's unimodal. So since that's primarily what we know how to talk about.